And we're live. Welcome back.
Perfect. Hi, thanks for joining us. I have a really exciting live interview with Michael Iantosca. Michael has a distinguished 43-year career in content industry, and 38 of those years were spent with IBM. The remainder of the years with Avalara Incorporated, where he serves as the Senior Director of Knowledge Platforms and Engineering. So his career began in information development as a technical writer and multimedia producer, and that evolved into other roles in enterprise content strategy. Without going too deep into it, you were foundational in the development of DITA, which was created as part of a structured content standard at IBM. Can you give us a little bit more insight about the evolution of your career from a content writer or technical writer to your work with IBM to start?
Thank you, Jessica, and thank you for having me
Sure.
today. I'm really thrilled to join and contribute what I can. I've been at this a long time. I started in the age of chisels and stone when it came to information development. There were literally people using typewriters when I joined still. We were mainframe, green screen. PCs didn't exist at the time. We were, like I said, PCs were just coming on the scene. I got one of the first ones off the IBM manufacturing line and took to it like water. When I started as a writer, for the first 5 or 10 years, I was a writer, planner, information architect, wrote, 24, 25 5-pound manuals about operating systems. And in IBM's grand wisdom, they sent us to programming school because we were writing about operating systems. So it turned into a hybrid engineer as well as a information developer, which is my core career. And I've pretty much done all the roles that you can imagine through my career as an information architect, as a content strategist, and a transformational content supply chain architect and developer. But in my heart, I'm still a writer and still an information architect and a content strategist. When I joined, we were using markup language actually at the time. IBM had invented markup language. A gentleman by the name of Charles Goldfarb invented what's called generalized markup language, GML, and he formalized it as SGML, structured generalized markup language, later in the mid 80s. That's when he cornered me because I was doing some patent work with audio and video in PC-based electronic books, which was kind of really new at the time. And he brought me over to the dark side. And I was one of the few people that could spell and understand what SGML, or Standard Generalized Markup Language, was. And I was going to the conferences, and we were trying to develop a lightweight version of SGML at the time. We called it monastic SGML as a joke for lightweight. And it became what you know today as XML. And I was there at the conference where Tim Bray and Gene Paoli and team were on the stage announcing it. And I came back to IBM and said to my CEO face to face in the same room of Louis Gerstner, and I said, we have this thing called XML, and it's not a Microsoft plot, don't worry. But there's a problem. There's no X really in XML. We need to make it truly extensible. And so I formed a small team of 10 or 12 people. We toiled for about 2 years and created DITA. And I want to be careful. Michael Priestley, my colleague, and who's at IBM and is now with me at Avalara, is really the genius behind DITA, the invention of it. I implemented the system, and it started an industry. But more importantly, we were focused on component content. We were moving from monolithic books to, monolithic books and chapters to componentized topic-based content with progressive disclosure and minimalism and all the things everybody on this call is just, completely understands. And we were trying to make content intelligent. We were trying to make the content machine intelligent as well as human intelligent. And that's really what I've been doing now for the last, gosh knows how many decades. We're at this precipice now where we built all this intelligence. We've broken down our content into architected forms, and the developers that are building the generative AI solutions seem to have no clue. They seem to think that we're still developing monolithic books and unstructured content and haven't architected this linked data with all of this intelligence that they're throwing into the garbage can with these vector retrieval augmented models. And what I've been working on for 3 years now, and we've just released, is a model that uses all the power of that intelligent content, whether it's DITA, whether it's Markdown, whether it's JSON, whether it's ASCII doc, RST. I can go down a long list. The model that we've developed is an open model built on open standards, and the entire project, which we did in collaboration with Semantic Web Company, they make Pool Party, was intended to prove that we could go far better than 99% of the models that are vector-based out there and get rid of this predictive retrieval that is the basis for almost every single model out there today. Sorry for the long diatribe.
No, it's great. No, because DITA, if we were to talk about broadly what problems DITA solves, it is componentizing content. It is structuring content broadly. Would you agree with that, Michael?
It is. It's broadly
Yeah.
about it, and it's
Yeah.
breaking it down into componentized related content with with each other, and that's the key. If you happen to be doing DITA or an XML or HTML dialect, we can get more mileage out of it with the knowledge graph based model that we're that we've published. We just published this massive 30-page paper and study. We didn't want to publish it until we had a full implementation, a working implementation. So I want to make a disclaimer. I have nothing to sell anybody on this call. Okay, I'm a practitioner, lifetime practitioner. I'm not a vendor. I'm not a tools seller. Just like we developed DITA and gave it to the industry, this model that we call the Document Object Graph RAG model is a gift to the industry. We want to see as many people benefit from it as possible. I don't know if I can comment. It seems like I can't make a comment here, but if you all go to my website, it's also on medium.com. If you go to thinkingdocumentation.com, that's my personal website, you can download the paper. As I said, it is written for information professionals primarily, and it breaks things down and makes it real. We can talk about ontologies theoretically all we want, but the way we wrote this was so that it was completely understandable to our rank and file information architects and content professionals and managers out there who can see a true, real implementation that works.
Yeah, and the paper was really fabulous. And actually, I would challenge anyone involved with training AI models or implementing AI models within any sort of environment, really consider the differences in how we might train a model and structure information and data in order to leverage structured content. So I want to dive into the paper a little bit. And the fact that you have a working model, I think, is very respectable that you waited until you had a working model before publishing. Many of our guests here and collaborators want to know what a DOM model or document object model is, which this paper is based on.
That's a really, really good question. So when we developed content, especially in the DITA world, we were using XML or JSON even, right? JSON is a similar document object model. A document object model, what it does is it organizes the content into a hierarchy of related documents. So if you're using DITA, anybody that uses DITA understands that we have a master file. We call it a DITA map, right? And in that DITA map, we can make a collection and call individual topics, either as a flat hierarchy or as a tree, okay? And everything in the collection, everything in the map is contained within something else. So it's very much an object-oriented like model that we can assign attributes or metadata about the things we're referencing. And if you happen to be in XML or SGML, all of the elements within the actual topics themselves are all containers. They're all contained within within another container. So a task topic is contained within a DITA map. So is a concept topic. But within, say, a task topic, you have a procedure and steps and and individual pieces. So it's an inheritance-based model. Now, Markdown and AsciiDoc, they have their own structure, but they may not be document object models themselves or quasi ones. We can actually augment them partially to do that. But we can include, say, DITA topics and Markdown topics and AsciiDoc topics in that DITA map, and it becomes part of a document object model. So you don't have to convert your content to DITA or XML to participate in a document object model. And that's how we built this system, which was, we said to ourselves, we have a real problem. Everybody wants a knowledge graph, and nobody wants to use the generated ones by the LLMs. That's giving away your intellectual property, right? And that's also giving away your domain. So, and they're pretty bad, actually, overall. What we want is architected knowledge graphs, and that's what you were talking about in the last session, actually, where you own the domain knowledge, you own the knowledge model, the actual ontologies for that. And the problem that everybody was having was it's too labor intensive to build a knowledge graph manually like that, right? I've watched companies do it, and maybe they can get a couple of hundred nodes or a couple of thousand nodes if they put a lot of people on it. But we're talking about our content consists of hundreds of thousands typically, or tens or hundreds or even millions of topics that we have in our collections. We can't build a knowledge graph that way. So what we were trying to do was automate the building of an architected knowledge graph. And what we discovered was there was a gentleman back in 2013, a year after Google released the knowledge graph model. And he figured out a way that anything that's a schema, anything that has a schema, like a database, right? And DITA, for example, could be the basis of it's equivalent to an ontology. It literally converts directly to an ontology. And then once we take that ontology, we can put it in a graph database, and then we can suck in the actual source content, all these topics in all these different formats, and it will automatically create a massive, accurate graph of the structural relationships of all of the content that we have with no human maintenance or updating or anything needed. We can keep it updated every night with automation. And once we have that graph, that knowledge graph, we can overlay it with a second ontology, which is our specific domain ontology. So I work in the tax space, right? Sales tax space. So I might have an ontology that declares that VAT is a European kind of tax, and Germany uses VAT, and that's a fact. So when we query the graph, we can use both the structural relationships that we painfully architected, right? We've said here's a concept, a task, and a reference topic that are all needed to answer a question. A traditional model that's out there that, as I said, covers 99% of the world today, can't retrieve more but one topic. Well, what if we have 2, 3, 4, 5, even topics that are distantly related, that aren't even in the same document? All that linked content all those links and knowledge of relationships is thrown away because they've chunked all this stuff up into vector databases, which are quite frankly stochastic, which is a fancy way of saying prediction based, right? They're guessing based on word frequency and closeness. And there's no way these models are going to get beyond a certain percentage of accuracy. So I asked the question, what constitutes good enough? Well, right now, we're currently in the honeymoon phase, right? Initial excitement. We've got a chatbot for support. That's going to wear off. And something called the precision paradox is going to kick in, right? Good enough, 40% deflection or 30% deflection is going to sound really good at first, but they want much higher than that, or 60 or 70% or 80% accuracy and hallucination, free of hallucination, is going to be good initially, and the disclaimers are going to fly nicely early on, but that's not going to fly. I mean, we're in the computing business, and we expect accuracy, and if we're going to move into the realm of of agents, right? Automated agents. How is predictive 70% of accuracy going to fly for agents that do things automatically for you based on these stochastic models? It's ludicrous to think that, we need super high 90%, and that, 95, 98, 99%. And that's where knowledge graphs, architected knowledge graphs over vector retrieval is going to get us there. And the industry is hot on knowledge graphs today. But as far as I know, we're one of the only ones that actually have a model that automatically will build the knowledge graph for you. And then you can add your overlay of your domain ontology to really allow it to do true inferencing and true reasoning, what we call true deterministic AI. And that's what's missing from 99.9% of these vector RAG models today.
If we dive into these vector models and vector databases, I want to expand a little bit more because it's so prevalent within the AI industry that we just use vectors to group concepts together to try to improve retrieval of information. I'm distinguishing that from information retrieval because it's the act of trying to assemble an answer to a prompt. So what are the challenges with vectors and content specifically? You mentioned that all of the sort of rich metadata gets stripped out. But can you expand on that some?
Oh, I would love to, because I think that, first of all, most of the folks on this call, they're information architects, right? Or related professionals. And you all need to lead right now. And in many cases, you're not. What happened is the engineering teams thought this was a coding problem, not a content and knowledge management issue. And as a result, their models are failing miserably for us in the content space. So I'm going to give you a laundry list, and I would like you to take out your pen and write down the ones that you want to use, because I think that you all need to go to your engineering teams if they're developing an in-house model, or go to your vendor who's selling you a model, and you need to ask them these questions. And this is how you can engage. In the last session, we talked about how do we as information architects and strategists engage with our IA, with our AI teams, right? Here's how. Okay? You need to start asking yourselves, how do they plan to really connect to your publishing operations management? How do they ensure that the changes that happen daily in volume are reflected in their retrieval model? How do they selectively unpublish content? You've just sold a product to another company, or you've discontinued it, yet you've trained your vector database with this content. How are you going to get rid of it? How are you going to put it out of business? How are you going to restore all the relationships that you architected in your content, whether it be structured data or whether it be some other way that you did with Markdown? How are you going to be able to do multi-hop retrieval to get topics that are needed, that are not closely related to the chunks that you shredded our information into when you shredded it into 4K chunks into these vector databases? How are you going to manage entitled content, right? You should be asking them this right now. You have a product, and the content for that product can only be received by people who have a valid license for that product, or you publish internal versions of the same or different content, and only internal employees are supposed to see those versions of content. How are they going to manage entitled content that we've been managing for years in our systems? More importantly, if you do version control, I used to come from IBM where we had, 10 or 11 versions of IBM DB2, right? Small business, enterprise version, version 1.2, version 6.6.4. How do you manage versions of content in your RAG model? More importantly, how do you manage conditional inclusion exclusion, what we call property-based retrieval, right? Sometimes we write a topic, and in the same topic, we literally write it for 3 or 4 different platforms, a version for Mac, a version for Windows, and a version for Linux. And we literally, with our content, with our structure in our content, can process that out so that we're producing a Windows-specific version how do you distinguish, first of all, between those different topics that are very similar to each other? And how do you honor that conditional control? How do you do change management for content classification if you do classify? How do you recognize the difference between topics that we've intentionally broke down as concept versus task versus reference versus Q&A versus API doc and so on and so forth? How do you know what kind of topic to retrieve for the customer in your RAG model, Mr. Developer? We've carefully classified that content and you threw it away. I can go on. There's a few others, like how do you do content accessibility and legal compliance and trademark compliance? How do you do unreleased content? How do we often are developing content that we want to publish, but we want to leave it, we want that trigger so that we can turn it on. How do you do revision management? How do you indicate to customers what's been revised? How do you personalize? And oh, here's a little one. How do you manage multilingual versions of our content? Are you going to set up 14 or 15 or 60 different vector databases, each of their own language? And what happens when we turn those into versions of language content? This is the tip of the iceberg. Okay, what I've discovered, and I read Medium and other places, other articles every morning. I probably read 10, 20 articles a day. I'm finding that the engineers are not content professionals. They don't understand professional information architecture and content management, and nobody yet is challenging them on these issues. And they need to be called on the carpet and say, you have to do these things. And if they think they're going to do this with those vector-based models, they're going to build monstrosities and workarounds that are going to collapse performance-wise to do them. And I sorry to have to speak the truth here, but we have to take the lead, and we need to ask them, how are they going to do all of these things and get to the high 90 percentile that they can't get to with these stochastic models?
Yeah, absolutely. And it's interesting, by throwing away that essential structure, that arrangement of these concepts, and to be able to connect content, to create or build what I call connected content. It's essential that we carry that modeling throughout the process of implementing AI. So if we look at this sort of informed system, and your approach that you've presented in this paper with Semantic Web Company is specifically working towards this graph RAG approach. So can you speak a little bit about not only the work that you've done, but were there metrics around accuracy and precision and recall that you can highlight from the paper?
Yeah, we did. I mean, we didn't even build out the full conceptual ontology. I mean, we only had a very minimal one, and we were already getting answers. Some of the beauty of this is we use a recommendation. When you use knowledge graphs, you can also have a recommendation engine built into it. And so literally, and I'll show this in the webinar on October 16th, Content Wrangler webinar. We'll show this live. As the customer is actually typing the question, we can query that. We're querying the graph, and we're generating different versions of the prompt based on the content in those components. They don't have to sit there and do prompt engineering. We're automating their own prompt engineering. So if I start typing in the question, give me the definition of, I don't know, what nexus is in the sales tax space. Literally, as they're typing in the question, even before they get to the end of it, they may have 5, 10, 15 different choices to finish that prompt and make a good prompt without having to conjure up in their brains, how do I actually write a prompt? We spend so much time telling people that they have got to become prompt engineers, and it has no relevance to the knowledge of the content that we already have in our system. So that was one thing that we were able to do very quickly. But what's really important when you talk about a knowledge graph and you talk about our content components is that the nodes of a knowledge graph, there are two types. One node represents the actual source file that we wrote, the actual topic file, and its connection to other topic files. And other nodes represent the concepts about the domain, like sales tax, and they all interrelate to one another. And we can put properties, metadata on those nodes so that when the query is issued, we could say, exclude all retired content, or only include content. This is only for internal people or entitled people. We can do personalization. So all the metadata that we've built and injected into our content operations and our content itself can be brought into that graph. And we can do all the things I talked about, every single one of them that these vector models can't do. And that's the magic that of using a true deterministic architected graph will give us. Yet they're still looking to build ways around all of this, because the first thing they were exposed to, these engineers, was Pinecone free, vector database. It took my chief programmer, I think 72 hours to build the first vector RAG model 3 years ago. And people think that vector RAG models are new. They're not. We all built them back then and said, oh my gosh, they're terrible. How do we get out of this predictive retrieval on top of a predictive LLM? We're headed for disaster long term.
Yeah, that's super interesting, because then we look at things like scalability and cost.
And
So
this is
yeah.
a simple model, by the way, extremely simple. It
Yeah.
doesn't require the massive infrastructures they're building. Now, oh, by the way, not everything is componentized topic content. We can include a traditional RAG vector model for the unstructured content in the same application. So they can coexist. But we would prefer the engineers understand the architecture of our content and utilize it, and not try to make us change our content to fit their models, which is going on now, believe it or not.
A lot of that, and we discussed this, is the idea of going back, the content's not working, so let's structure the content for AI rather than keeping it consumable for humans. And that's an issue that it pulls the thread of IA from front end to back end, and really joins the two sort of practices, the UI UX, with because this our primary goal is and in a lot of these cases may be for information retrieval, and distinguishing between information retrieval for machines and information retrieval for humans. Can you speak a little bit about that?
Yeah, I mean, we're pretty good at information retrieval for humans, and we've been honing our search optimization, our search and our content delivery systems to do that. As we develop taxonomies and ontologies, we can augment our existing content with more of it, right? Especially the ontologies that people are just starting to do. I hired my first ontologist 3 years ago, and I wrote in one of the CIDM articles that I published that sooner or later companies are going to be recruiting freshmen out of library science programs left and right. What I would recommend is that every information architect now needs to team up with, or even become, an ontologist and understand how this stuff works. Because we're melding information architecture and knowledge management, and those two worlds have traditionally been separate. I started with AI in 1990 with expert systems. I was doing, Lisp and Prolog, and that evolved. And with IBM, with Watson, I worked with IBM Research, who were these linguistic scientists. And what I realized was there's a lot of resources out there that you can very quickly learn all about taxonomy, ontology, and knowledge graphs. And I think the paper that we have tries to make it touchable for people in our discipline.
Yeah, that's wonderful. This has been such a great session. I wish we had more time, but I do believe that we're going to have a nice forum later where we're going to be able to discuss these things more in depth. Are there any closing words? I know that we've shared your website, thinking documentation.
Yeah, please do. It's a fun website. I don't have too much content out there, but what's out there should be pretty interesting. I'm pretty vocal, as you can tell.
Yes, I'm a longtime fan of many of your articles and posts on LinkedIn, so I do encourage anyone who's watching this to check out Michael's. Yeah.
what I want to do is I want to encourage all, especially the information architects and strategists and professionals on this call. This is going to require that you take the lead and that you challenge your providers directly. Hopefully, I've given you some fodder to do that with.
Well,
I know
and Margaret Warren has requested that you publish the lists that you provided during this interview. So, you know,
yeah,
that's a strong. I would second that request. It was a great,
yeah,
great
yeah,
list.
and I definitely
Yeah,
will give it to you, and you can share that out. For some reason, I can't put a comment in here. I would have cut and pasted it in.
that's okay.
But thank you so much for the time. And oh, by the way, like I said, on October 16th, we're going to have this 90-minute session where we're going to walk through the model. And I really encourage people to attend. We have, I don't know, 25,000 downloads of the paper and over 600 to 700 people signed up for this webinar. Not just content people in the industry are just gravitating, and they really want to understand how did we magically figure out how to do this with the automated.
It's an amazing paper. It's an amazing paper. And I've actually tried my hand at implementing something with Markdown similar to this for AI. And I will tell you it works. So thank you.
Thank you.
All right. So I think that we have a break, a small